Assalamu alaikum. I am Faisal Ahmed. I am from CSE department and I am currently in my 7th semester. Today we will discuss about a question that was given to us. The question was we have to prepare a design for a parking garage that will hold up to 10 cars. In this figure we have to display that there have to be a keypad that will input the maximum number of cars that can store in this garage, and when the garage is full it will display the word full, and when the garage is not full it will display the word space available in a blinking manner. Now for the question, for the first questions they told us to draw a block diagram and a flow diagram of the design and how it will display the word full or space available. Based on sensor data we have to explain that. Now we will explain the question. We have designed a system to count cars 0 to 10 using sensors entry and exit point. This design will display the word full when garage is full and display the word space available in a blinking manner otherwise. We have used keypad, 16 to 4 encoder, entry and exit sensors, counters and 555 timers for display function in this design. The use 16 to 4 encoder is to enter the maximum number of amount that car that this garage can hold. And then we use the 4-bit PIPO register to store or to shift the numbers. We use comparators to check the amount of cars so that we can know when there will be a, a display of full and when there will be a display of space available word. We have also used two 555 timer to display the words properly. 555 timer 1 will display the word full and 555 timer 2 will display the word space available. Here is the block diagram of the design. And then there is the flow diagram where we can see how the comparator works for input A and for input B. Then there is the time circuit and comparators. How the time circuit and comparator works, we can see that here. When A and B is equal, that means the display will show the word full, and when input A is greater than input B, then it will display the word space available, as there is still places for car B. At last, we have shown the 4-bit up-down synchronous counter as was asked in the question. When the car enter the garage, it will increment the number, and when the car exit the garage, it will decrement the number, as we have shown in the circuit diagram. As for question number 2, we have to explain how both of these 12 timers works. For 12 timer 1, we have it will work as a continuous output and it will display the word full when all the conditions are met. So as it has to work in a continuous mode, 555 timer works in a monostable mode where it can display continuously. And for 555 timer 2, we have to show the word space available in a blinking fashion when the garage is not full, and to show that we have to make the 555 timer work in a stable mode where it will work not continuously but it will work in progress. When it will ask or higher number of high input, it will show the word is available, and for lower it will show the word. There is a circuit diagram for timer 1, and there is also the calculation of duty cycle for the 555 timers. And then for a stable mode, you can see the stable mode we have also calculated the numbers of the higher input and lower input, and we have also designed the circuit diagram for both of the timers. Now for the question number 3, we have been asked to design a FSM design architect and architect the and here is the FSM design. You can see that, and then there is the state diagram, and then there is a state table. In state table, there is present state and next state, and there is also the output for A and B, and then there is the output equation for A and output equation for B. Then we have written the Verilog HDL code for the FSM architecture or assignments. Here you can find the full HDL Verilog code. And thus we have finished the question number 3. In question number 4, we have been asked the limitations of this parking system we have designed and how we can improve these limitations. And if we improve these limitations, what will be the effects? As for the limitations, we can summarize that the main problem we are facing is with the T12 timer. The T12 timer cannot be paused, and there is no enable pin for the T12 timer. And also the capacity of the car is always fixed. We can't go more, we can't store more cars in this garage. As for the solution, we can obviously you can replace the timer with microcontroller, something like Arduino to dynamically control it. So we can control the input and output or entry or exit of the cars. And then if we want to increase the number of capacity for cars in our garage, we can also change the counter from 4-bit to 8-bit so that we can store more cars. If we use an 8-bit counter, it can store up to 255 cars. So I guess it will solve our limitations. But if we modify those changes, there will be some impact of the changes in the garage or in the system. The one of them is potentially it will cost us more than the current one, but it will be more suitable and stable. The larger counter, more complex wiring and circuit design. As we know, when we use more complex and large counter, it will be hard to design, and but it will be easier to adjust the parameters like blinking rates or capacity. So we can see that there is both pros and cons in the changes. So that's all from me. Thanks for the hearing. I guess we have discussed all the problems and how we can solve them. Thank you.